Right, section 10.2, we're going to start talking about rational exponents. So we have several different expressions to evaluate that involve rational exponents. Rational exponent basically is a fancy name for an exponent that is a fraction. If you remember from the last section, I briefly mentioned that if you have the fourth power, that means the same as the fourth root. The 1/4 power is the fourth root. Now if you see an expression like this, with a negative, you have to follow order of operations. Order of operations tells us we have to do the exponent first and then apply the negative. So we take 256 to the 1/4 power and then apply the negative. This is the same as negative fourth root of 256. Now there is a way to do fractional powers on a calculator, and I could show you that, or you could use the fourth root. So fractional powers, if I take 256, see this? So clear this all out. All right, 256, I use the caret key, and I want to take that to the 1/4 power. I'm going to use parentheses here, and I'll do 1, my fraction button, my ABC button, to the 1/4 power. And that'll tell me we get 4, right? So what we end up with here is a -4. You could also do the fourth root if you prefer that, and you should already know how to do that, right? So either way, we get -4. 16 to the 1/2 power, again, that's the same thing as the square root of 16. This one's pretty easy, right? Because what's the square root of 16? Well, that's just 4. Next one we have, notice the negatives in parentheses. So we have to honor those parentheses, and this is the same thing as the cube root of -3375. All right? So either way you evaluate this, with the fractional power or the third root, you should get the same answer. For this one, I might go ahead and do the cube root. We know how to do that, but just to model it, second, I'm going to use, oh wait, we got to do 3 for the cube root, right? 3, so see this a little better. Second, the x root, and then I'm going to parentheses -3375. And let's see what we get. -15. If you do the fractional power, I would do parentheses -3375, use the caret key, and raise that to the 1/3 power. And if you don't want to use the fraction bar, you could just do 1 divided by 3. Either way, we should get our same answer of -15. So that's just making sure, I mean, really, we can make sure we know that the fractional power is the same as the root, and being able to use our calculator whichever way you prefer. Okay. All right, so we have some others here. Again, we can really just plug these into our calculator and see what we get. If there's a negative and there are no parentheses, again, we do the power first, right? So I'm going to do 81 to the 5/4 power. We'll see what that is. That's 243, and we apply the negative. Right? So this ends up being -243. The next one, do 36 to the 5/2. Let's see if I can do that. So 36 to the, I'm going to use parentheses, the 5/2, and you can use the fraction bar, or you can use the division symbol, 5 divided by 2. 7776. All right, so these are just really plug and chug. Just making sure you know how to use your calculator on a lot of these. The next one is kind of messy, but we can do it. We got to make sure we use parentheses appropriately. So in parentheses, I'm going to write the fraction 125 over 27. And I'm going to take this to the -2/3 power, so the -2/3 power. Let's see what happens. We get a fractional answer, 9/25. Now if you start with a fraction, I would recommend using the fraction button, not the division symbol. Because if you use the division symbol, it will probably give you a decimal answer, which is not going to be exact. It'll be rounded in some way, most likely. But here we get 9/25, just using our calculator, right? I'm going to see what happens if I use the division symbol instead of the fraction bar symbol here. So if I use, let's say, 125 divided by 27, and then let's say if I take this to the -2 divided by 3, instead of the fraction button, if I do this, let's see what happens. Yeah, I get a decimal. It's an exact decimal, and that would be fine and correct. Just one caution that sometimes you'll get a repeating decimal here, which is not going to be good. So 0.36 would be okay in this case because it is a terminating decimal. But with a repeating decimal, there's no real good way to write that in my lab. So I would suggest using the fraction button instead of the division symbol on these problems. Alright, so let's look down here. What are we doing? We're asked to evaluate this exponential. Let's see. 4y to the 2/5 plus 5x to the 1/5. So I think there's no way to evaluate these. In fact, I should have a different set of instructions, and maybe I should say to simplify these. If it's possible at all. The problem is, a lot of these are both good examples of really not being able to do a whole lot of anything. We can't do anything here. We can't actually take 4 to the 2/5 because this 2/5 goes with the y, only the y. For this guy, we could take them both to the 1/5, and because we have this in parentheses, but what would that do for us? Would it really do anything? No, not really. So there's really not a whole lot we can do to simplify this. And this is a good example of not being able to do a whole lot of anything. 4y to the 2/5 plus 5x to the 1/5 is about as simple as you can get. Okay. Now, the one thing you could do again is you could apply the 1/5 to both of these, but 5 to the 1/5 is not going to be a nice number. You can try that. Here, notice these two things in parentheses are held together by subtraction. If there were a multiplication here, we might be able to apply this power to both parts, but it's not multiplication, it's subtraction. Similar to if I had something like x plus y, I don't know, squared. We can't square both parts. We'd have to FOIL this out, x plus y times x plus y. So this is really about as simple as you can get. The one thing that you might want to do here, because mathematicians like this, is to write this without a negative exponent. And we'll run into this in later on in this chapter. If possible, we would like to write an expression without a negative exponent. If you have a negative exponent, all it does is the reciprocal of the positive exponent. So what we could do here to make this more mathematician friendly is to put 1 over this expression, 2x to the 4th minus 3y squared, to the positive 4/3. That's equivalent to that expression to the negative 4/3. And this is the answer, and a lot of times you'll be asked in my lab, and if I were teaching this class and we were doing paper assignments, I would ask you too to write this expression without a negative exponent. And the way to do that is take the reciprocal of the expression and write it with a positive exponent. Okay? So here we can do something anyway. We can write this as 2x to the 4th minus 3y squared to the positive 4/3. And we don't have any negative exponents in our answer, which is the preferred traditional way to write an answer involving exponents. Okay. All right, so that's it for page 1 of 10.2. We'll continue on the next page in the next video.